Hello dear student. Today we are going to talk about antibiotics, especially antibacterial drugs. Group of antibacterial drugs which can inhibit synthesis of cell wall of bacteria, or in another way to say bacterial cell wall synthesis inhibitor. So group of antibiotic it's cyclosermine, bacitracin, vancomycin and beta-lactam. So these four main groups, cyclosermine, bacitracin, vancomycin and beta-lactam. And also in beta-lactam we have four main groups, penicillin, cephalosporin, carbapenem, azithromycin. So in this group, two drugs it's main, penicillin and cephalosporin. It's the most common drugs which we are using, most common antibiotic. So now I'm gonna detail of structure of the bacterial cell wall. What is the normal structure of bacterial cell wall? If we take two bacteria, one it's gram positive, another is gram negative. For example, gram positive we will take Staphylococcus, gram negative we will take Escherichia coli or any other bacteria. In Staphylococcus, here we can say it's cytoplasmic membrane of Staphylococcus. Here peptidoglycan. Here we have cross-linked via peptidic change, sugar backbone. Here this part is sugar backbone. This is penicillin binding protein. So this one it's the structure of 1 gram positive bacteria, which includes cross-linked via peptidic change, sugar backbone, peptidoglycan, which all is called peptidoglycan, and penicillin binding protein. Here, these ones are called penicillin binding protein. Later I will tell you how penicillin bind to these proteins and act on the bacteria, and it will kill the bacteria. Now we are going to detail for gram structure of gram negative bacteria. Structure, it's for example cross-linked peptide as a gram positive. In gram negative also we have peptidoglycan, we have in gram negative, but the main difference which we don't have in gram positive, in gram negative we have additional membrane. This is called additional membrane of gram negative Escherichia coli. So this additional membrane have the big roles for deactivating penicillin. Penicillin is coming to this bacteria, but it can't activate on the bacteria because of additional membrane, additional cytoplasmic membrane. But this additional membrane we don't have in gram positive bacteria. That's why penicillin can have the effect on gram positive bacteria, but it can't affect on gram negative bacteria. So now we can explain what's the difference between gram negative bacteria and gram positive bacteria. In gram negative bacteria, as we see, the wall is thick, but in gram negative bacteria is thin. So wall is thinner than gram positive bacteria. It's the first difference. The second difference between gram positive bacteria and gram negative bacteria, it's in gram positive bacteria no additional membrane, but in gram negative bacteria there is additional membrane. So Here we can, as I draw for you here, penicillin G, which can come and can cross the pore and go and bind with the penicillin binding protein and kill the bacteria. But here, penicillin, it can come to, when it's coming to gram-negative bacteria, it have no effect on gram-negative bacteria because of additional membrane. So penicillin will not act on gram-negative bacteria. Here we can divide, I divide for you penicillin in two parts. Penicillin, it can be divided in wide spectrum and narrow spectrum. And narrow spectrum also we can divide by natural penicillin and very, very narrow spectrum. So natural penicillin, it can be divided by two, penicillin G and penicillin V. So it's the most important thing you have to know, that natural penicillin, it can be divided by two, penicillin G and penicillin V. So here those drugs, as I said, the drugs which can work on gram-positive and gram-negative bacteria, they are different. Penicillin G, as I said, it's fail on gram-negative bacilli. Why they fail? Because they have narrow pore. So here we have wide pore, but here very, very narrow pore. So the bacteria cannot go inside the pore and reach to cytoplasmic membrane and kill the bacteria. But here we have wide pore. Here this is called pore. So bacteria can go inside the antibiotic penicillin can go through the pore and reach the penicillin binding protein and act on cytoplasmic membrane and destroy the bacteria. But here it cannot do that activity. So natural penicillin, it can act on what? Natural penicillin, it can act, as I say, natural penicillin, it's penicillin G and penicillin V. Natural penicillin, it can work on gram-positive cocci, gram-positive bacilli, and a few gram-negative cocci. But also, natural penicillin, it's fail on gram-negative bacilli. Also, natural penicillin, they can act on spirochete. Here they can natural penicillin, as I say, they can act on spirochete, and also so that you will see the picture better. And also natural penicillin, they can act on Treponema pallidum. Treponema pallidum, it's where? Treponema pallidum, it's present between the tongue and lips, which as a result, which produce this Treponema pallidum is produce what? Produce syphilis. So penicillin G, it can affect on syphilis. So we have, as I said in previous page, like we have natural penicillin, it's penicillin G, penicillin V, and also we have the other type, as I say, there is narrow spectrum and very, very narrow spectrum. So now I'm going to detail talking about very narrow spectrum. It's what's the very narrow spectrum? It's anti-staphylococcal penicillin. So this anti-staphylococcal penicillin, they can work on staphylococcus. So then, example, why we will go to these drugs? If the antibiotic, it won't act, we will move to very narrow spectrum. Why we will go, why we will move, I will explain later. So the example of anti-staphylococcal penicillin is fluoxetine, methicillin, nefacillin, uh, cloxacillin, and dicloxacillin. So these drugs you have to remember. When we will move to this uh, anti-staphylococcal penicillin, when we start killing staphylococcus and with penicillin without any human, right, staphylococcus starts producing gun for protecting himself. The gun which staphylococcus is producing, it's called penicillinases. So as we see here, for example, if here staphylococcus gram positive here, it's producing what? This is special gun. It's called penicillinases. So staphylococcus it's producing penicillinases so that it will kill the bacteria. So when bacteria it's reach to staphylococcus, when it want it's go and to kill, to destroy cytoplasmic membrane of staphylococcus, it's starting producing this enzyme which call it penicillinases. So the enzyme it will go and break the ring of penicillin. Here we can see ring of penicillin. By this ring penicillin it's going to bind the protein, binding protein which I explained in previous paper. So when this ring it's destroyed by penicillinases, so penicillin cannot bind with protein binding protein and it won't have effect on gram-positive bacteria. So in this case we will move to what? To anti-staphylococcal penicillin, which is these drugs. So we see I explained here for you, it's destroy the penicillin reach to the staphylococcus. So what will we do? For the protection of cutting, for protection of ring of the penicillin, we will give these drugs: cloxacillin, dicloxacillin, nefacillin, or fluoxetine. So what they will do, these drugs, they will protect the penicillin by this, like protection of the ring, like they will put like that, and to the penicillin. So but these drugs when we are given it have some side effects. For example, nefacillin it have side effects, like it can causes like nephritis, neutropenia. So it's a big problem for these drugs. Now I'm going to detail the talk about before talk about difference between penicillin G and penicillin V. I just want to repeat so that you will understand better. So when we start killing I will go to repeat this why we will use this anti-staphylococcal penicillin. When we start killing staphylococcus with penicillin, so staphylococcus start producing penicillinases. It's producing special, as how we can say, special gun for protecting himself. Then penicillin tried to attack, but it's failed to attack the bacteria because of the penicillinases. After that situation, we can go and move to anti-staphylococcal penicillin. Then the drugs it can go and bind to penicillin binding protein, and But in these cases, the antibiotic, it can have very big effect on the bacteria and can kill, even if bacteria is producing penicillinases. So now I'm going to detail talking about another way that I want to tell you. These drugs, for example, penicillin G, these drugs can be given orally. For example, cloxacillin, decloxacillin, and fluoxacillin. If there is O, so we can say we can give orally. So now the difference between penicillin G and penicillin V. Penicillin G, it can be given parenterally, but penicillin V, it can be given orally. Why we can give penicillin G parenterally? Because if we will give penicillin G orally, so when it is going to the stomach, it's when we are giving, if we are giving penicillin G orally, it will go to the stomach, and acid of the stomach gets attack and destroy these rings of the penicillin, and it can't bind to penicillin binding protein. That's why orally it's not very effective, only IV or parenterally. Penicillin V, it can be given orally. So penicillin V, it can be given orally. Why? Because there is special they have special protection, so that they can protect from the acid in the stomach. So this drugs, penicillin V, we can give for oral infection. So in two conditions which we can use penicillin V, it's kids for rheumatic fever and oral infection. So this drugs, penicillin V, it can be given in those bacteria which they can produce penicillinases. There is here in some case when we are giving anti-staphylococcal penicillin, it's also this antibiotics also they can fail. Then the doctor, when this bacteria it can fail, the doctor get abscess really, and there is, we can call the upper gun of the staphylococcal it's become. So we can call we can give even methicillin resistant staphylococcus, EMRSA. So in this case we can move to vancomycin. So we will move, and also we can move to those penicillin which can work on gram-negative also. The group is what? It's wide spectrum. Wide spectrum, it can be what? It can be ampicillin and amoxicillin. And also we can call this two type of drugs, we can call smart penicillin, which can attack gram-negative and gram-positive. So here we can say they help to clear enterococci. So the word of helps, I bring, it's for five, it can have 5 action. It can have action on what? Haemophilus influenza, H for Haemophilus influenza, gram-negative, which gram-negative. So as I said, wide spectrum, it can have effect on gram-negative and gram-positive bacteria. So H, which standing for Haemophilus influenza, it's gram negative. So ampicillin can have effect on this Haemophilus influenza. E, it's for Escherichia coli, which is also gram negative. L, for Listeria monocytogenesis, which is gram positive. P, it's for Proteus. Be careful, it's not Pseudomonas. S, it's for Salmonella. So ampicillin, amoxicillin, it can have act on this bacteria. So another way in gram-negative bacteria, gram-negative bacteria can produce what? Can produce endotoxin. Endotoxin. So lipopolysaccharide is present on what? On gram-negative bacteria. But one way we have to be very careful. Amoxicillin, which also call it smart penicillin. They have small side chain so that they can pass through the pore gram-negative and gram-positive. So this is very small, so they can pass through the pore. When we give amoxicillin, you add clavulanic acid. Why we will add clavulanic acid with amoxicillin? It's for protection of amoxicillin against what? Against beta-lactamase. So it's like a weapon for protection of amoxicillin. So we will give clavulanic acid. What clavulanic acid will do? When we give clavulanic acid, it will come and it will bind to what? To beta-lactamases. And beta-lactam, it will be busy. Beta-lactamases, or we can say penicillinases, can be busy with what? With clavulanic acid, and then they cannot destroy this part of amoxicillin. So amoxicillin can reach to the cytoplasmic membrane and go to inside the bacteria and kill the bacteria. So anti-beta-lactam. So anti-beta-lactam are, as I said, it's clavulanic acid, sulbactam, tazobactam. You can give each of them or one of them. Like you either you will give clavulanic acid, either sulbactam, either tazobactam. With what? With amoxicillin or penicillin or ampicillin, sorry. So as I wrote here also for you guys, these drugs go with penicillin and protect them from the staphylococcus, from the penicillinases. So the body gun of amoxicillin is clavulanic acid. The body gun of ampicillin is what? Is sulbactam. In market, it's called inacin. So inacin, they are selling in most of market, they are selling by this name, inacin. So in some cases, in very unfortunate cases, when for example, if there is some wound of the patient, when there is surgeon is opening the wound and surgeon it will see the green pus, and it's a very bad situation because in the wound, if there is green pus is produced by the organism, it's called Pseudomonas aeruginosa. So Pseudomonas aeruginosa, it can protect himself very, very strongly, because Pseudomonas aeruginosa, it have very, very few pore, So the bacteria amoxicillin and antibiotic like amoxicillin and ampicillin, it can never reach to the bacteria and kill the bacteria. So penicillin, it cannot go to the bacteria. So in this case, we will move to which type of drug? We will move to super smart penicillin, which call it anti-pseudomonal penicillin. So these drugs, they can go through very small pore, and they can destroy the pseudomonas. Here, so these drugs, we can say it's called supermodel drug, anti-pseudomonal drugs. Also, we can call this type of drug, it's like anti-pseudomonal drug. So the drugs, it's 5 drugs. It's called like piperacillin. It's a little bit for memorizing. Piperacillin, just memorize like piperacillin. It's like it have special bomb for protecting themselves. This one, it's most powerful. Ticaracillin, it's have biological act, like biological bomb for protection of for killing the bacteria. And also azilocillin and carbenicillin. So this is its second name. You can use only this one. So piperacillin, ticaracillin, and carbenicillin, azinicillin and mesilocillin also. So the most powerful is piperacillin. Just remember, like it have special bomb for killing the bacteria. It's the most powerful. So with piperacillin, we can give tazobactam or what, or sulbactam. We can give tazobactam. It's like tazobactam or sulbactam. It's not different which kind of them you are using. So it's better now for piperacillin we can use tazobactam for protection. So tazobactam, in the market they are selling by Zocin. It's called Zocin for protection of the bacteria. So ticaracillin also, it have special biological bomb for killing the bacteria. So this ticaracillin we can give with clavulanic acid. So clavulanic acid is selling in the market by Timentin. So carbenicillin also we can give. It's carbenicillin, we can just remember it have special car to go inside the pore and read the bacteria. Thank you very much. I hope it was helpful for you.